All right, so you're gearing up for that big CBSE physics exam, right? And you know that it's about way more than just memorizing a bunch of formulas. In this explainer, we're going to do something different. We're going to decode the exam itself. We're going to learn how to think like the person who writes the questions, how to spot the little traps they set for you, and really master the mindset that sets the top scorers apart. Let's dive in.
So you know the Lorentz force equation, F equals Q times V cross B. You've probably written it down 100 times. So why is it that when you see it on an exam, it suddenly feels like a trick question? Well, it's because exams aren't just testing what you know, they're testing if you can spot the predictable traps that are designed to catch the most common mistakes. Knowing the formula is really just step one. The real challenge is seeing the pitfalls the examiner builds right into the question. And today, we're going to pull back that curtain and break down exactly what those traps are. You see, knowing the formula is just your ticket to the game. The real test, the thing that gets you the points, is identifying those pitfalls an examiner intentionally puts in your way. And that's what we're going to do right now, break them down one by one.
Okay, let's start with the absolute biggest category of traps, vector directions and forces. This is where countless marks are just lost. And it's usually because of a simple mistake, like a misplaced sign or a little misunderstanding of something like the right-hand rule. Let's look at this one. It's a total classic. A question just like this, or a slight variation of it, is almost guaranteed to show up. You've got a proton, a velocity, a magnetic field. It seems so straightforward, but it's the perfect setup for a very common slip-up.
And this slide right here shows the difference between just an okay answer and a top-scoring one. The common mistake is just rushing through it and getting the cross product backward. But the secret to getting full marks is to be explicit. Actually write down the rule you used. Show that you calculated plus x hat cross plus z hat to get negative y hat. It proves you aren't just guessing, you know the process.
And here's the core physics principle that helps you avoid these mistakes in the first place. The magnetic force is always perpendicular to the plane made by the velocity in the field. Now, what does that mean? It means the magnetic force can't do any work. It can't speed a particle up or slow it down, it can only change its direction. Remembering this is like having a built-in fact checker for your answer.
Okay, now let's use that same kind of thinking for another really common question. This one involves two parallel wires, and it tests a slightly different kind of directional reasoning. The trap here is so sneaky because it plays on your intuition from electrostatics. I mean, we've had it drilled into our heads with charges, opposites attract. So your brain sees opposite directions and immediately wants to jump to attract. The expert move? Pause. In your head or even on the paper, state the rule for currents first. Same attracts, opposite repels. So in this case, opposite currents, they repel. It's a simple little mental check that saves you from a really costly mistake.
And just think about how important this is. This isn't just some random fact for an exam. This principle is so fundamental that the force between two parallel wires is literally the basis for the SI definition of the ampere. So yeah, it's not a minor detail. It's a cornerstone of this whole topic.
Okay, on to the next major category of exam traps, the formula mix-up. This is what happens when you've got a bunch of formulas for situations that look kind of similar, and under pressure, you just grab the wrong one. Let's call it the geometry trap.
This is a classic example of that geometry trap. You know there's a specific formula for the magnetic field inside a solenoid, but can you pull out the exact right one under exam pressure? The examiner knows there are very similar formulas for a long wire and for a toroid, and they are basically betting that you're going to get them confused. The common error is pretty simple, just mixing up the formulas. But if you want to really impress an examiner, don't just give the right answer, B equals mu naught Ni. Show that you have a deeper understanding. Add that the field outside an ideal long solenoid is approximately 0. That little addition proves you understand the entire physical system, not just one isolated equation.
Let's just put them all side by side for a second. Look how similar but how different they are. A long wire's field depends on r, the distance. An ideal solenoid's field is uniform inside and depends on n, the turns per unit length. And the toroid, well, it brings back that r dependence but uses n, the total number of turns. Seeing them all together makes it crystal clear how easy it would be to get them jumbled under pressure.
So we've broken down the traps, we've seen what the examiner's trying to do. Now the big question, how do we build a defense? This final section pulls everything we've talked about into one simple, actionable checklist you can use on every single problem. This really brings us to the most important point of all. It's a shift in your mindset. You have to stop just passively solving problems, looking for the right answer. Instead, you need to start actively hunting for the errors before they can happen.
Become an error hunter. That is the single biggest thing that separates a good student from a top scorer.
So here it is, your protocol. 5 simple steps to run through on every problem. Number 1, identify the particle. Is it a proton, an electron, an alpha particle? This affects the charge, the mass, and remember, you have to flip the force direction for negative charges. 2, check the angle. Is that sine theta factor important here? Don't forget, if the velocity is parallel to the field, the force is 0. 3, convert all units. Did they give you centimeters? You have to convert to meters before you do anything else. 4, apply the right-hand rule consistently. Do it carefully and again, flip it for electrons. And finally, number 5, distinguish the device. Is it a wire, a solenoid, a toroid? Use the exact right formula for that specific situation. This checklist is your ultimate defense against the most common traps.
So I'll leave you with this one question. The next time you sit down with a physics problem, what's your first move going to be? Are you going to rush in and just start looking for a formula that fits? Or are you going to pause and with an examiner's eye, start hunting for the trap? That choice is going to make all the difference.